Hi, it's Jocelyn. This is Advent of Code Day 14. Alright, so we have something at the top, just a string of letters, and then we have maps from 2 letters to 1 letter. Extended polymerization. Okay. So these happen simultaneously. So we figure out what we need to insert and then we insert them, it looks like. Okay, yeah, list that here. These pairs overlap. The second element of one pair is the first element of the next. So we're adding, so we're doing NN becomes NCN. Okay. After 10 steps of pair insertions, the polymer template. We want to find the most and least common elements. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? Okay, so first of all, let's just do the parsing. So similar to what we did for day 13, we'll say lines is equal to that. Our input, the input or the template is this. So we'll say template is equal to lines dot next dot unwrap. That's just the first line. The second line we just ignore. And now we're just going to parse the different reactions. So we'll say pattern and addition is equal to line dot split once at the arrow. And these are, okay, so addition is just going to be a single character, so we'll just say that will just get the first one. So we'll say reactions, this should be mutable, is a hash map. Okay. And it's a hash map from a string, which is 2 characters, to a char. I actually kind of want, I think that having 2 chars is probably a little bit easier than the string, so we'll do that too. So we'll say P1 is equal to pattern, this is exactly the same thing. Actually we'll say let pattern equals pattern dot chars. And we'll take the first and the second one. Now we can insert these into our reactions. So reactions dot insert P1, P2, and in the middle we're going to add addition. So now we just need to do this 10 times. So for I in 0 to 10, we're going to look at the string, figure out what we need to insert, and then we're going to insert them. So we'll say insertions is equal to empty ec, and we'll add to it as we go along. So for IC in, actually what I'm just going to do for I in template, let's see. First of all, this is going to be easier as a vector of chars rather than a string, so I'm going to convert it into that. So it's just going to be chars.collect, and this is now going to be a vec of chars. Strings in Rust are a little bit trickier. And I think for the, like, we might run into efficiency problems with this. That's very likely actually, but for now I'm just going to use a vec. For 10 that should be fine. or 10 iterations, that should be fine. So for, actually this doesn't need, we don't need to keep track of that number. So for I in 0 to templates.len, we're going to, actually I'm going to start at 1. And we're going to look at the character before and the character after. So that is p1 is equal to templates at I, and p2, or I minus 1, and p2 is that. So if there's a reaction for that, so if let sum addition is equal to, let's see, it's equal to reactions dot get, and that will just be p1, p2. Then we're going to add to insertions. So insertions dot push. So we want the location that we need to add it to, which you need to think about. So we're adding it right before the second one. So right before the second one should be I. We'll double check that with an example. And we need the addition. And that's a reference to a char, so we need the star there. We need to dereference that. Okay, after that, then we need to process the insertions. If we do it from start to end, we have to keep on adding to I, but if we do it in reverse, then we can keep the indices the same. So for IC in insertions dot iter dot reverse, beautiful. We can actually even do into iter. We're going to say template dot insert. This is going to be a U size, or this is going to be, the index is going to be I, and the character is going to be C. So that should be good. I'm going to use the example for sure. Also, we need the most common and least common. So let's see, what's the best way of doing that? I wonder if there's like a most common function. Let's do counts. Counts is equal to hash map. No. And for C in our template, we're just going to say counts.entry C, or default, which is 0, plus equals 1. Does that compile okay? Let's see if we have any errors so far. This should be template. Looks like that's okay though. So here now we need to then figure out the most common and the least common. So that's going to be the character and the count. We just care about the count. But then we, at the end, just care about the character. And the least common is going to be pretty similar. It's just going to be min by key. And it says we want the most common minus the least common. And because there's subtraction here, I'm just going to use my 64. Not that it matters particularly much. Just our types will match up this way. Oh, no, we just care what the counts rather. We don't care what the letters at all. Okay, and then we have our example, and that should give 1588. Let's see if it does. it looks like that passes. So now let's run our test for part 1. Okay, 2851. All right, let's go to part 2. So for part 2, we need to actually do 40 steps. I feel like we might have to use a different data structure for this. So part 1 and part 2 are going to look quite similar actually, and we have a nice way of making sure we didn't break it. So and that's going to be 10. And over here, it's going to also be 10. Oops. And we have the same example. Except this time with 40 iterations, it gives us a much larger number. I'm actually going to switch this back to usize. Shouldn't matter. I'm going to switch back to usize anyway. So already we see like it's not finishing right away. So let's see how fast this is going. Doesn't actually need to be a debug thing. Anyway, what this looks like is like, it looks like the idea here is that we should make a linked list. A linked list is not actually something that is very practical in Rust. However, what is practical, I'm just going to stop this just to reduce CPU because that's like obviously too slow. What is practical is a hash map from one item to the next. So we're going to kind of redo how we do our template. Okay, so instead what we're going to have is a hash map from just like a pointer, which will be of type usize. I'll explain what I mean by pointer in a second. And it's going to point to, or it's going to contain both the next item, which is the usize or pointer to the next item, and then also what character it is. And we're going to say here for I and C in something that's like this. We're going to enumerate them. We're going to say template dot insert IC, and we're going to say max pointer, that's going to start at 0, max pointer is equal to I, and only the last time that we set max pointer to I matters. We can avoid like an extra line down below to see how many lines there were or something. Okay, so now every time we interact with template, we're going to need to do something different. Can we get away with this? So this is like just a singly linked list. I'm trying to think if we can get away with just making a singly linked list. I think we can if we're careful. If not, we'll come back to this later. So the template always starts at pointer 0. So this is going to be a loop. Oh, of course it can end eventually. Sorry, I messed this up a little bit. So this is going to be an option usize because it can be none. So it's going to be sum I plus 1, unless it's the last one, so I guess my cleverness here doesn't really work. Let's see. Okay. I guess we're going to keep what we had before, and then just go first line dot iter dot enumerate first line dot len, and here we're going to say if I plus 1 is equal to max pointer, then none, otherwise it's okay, something like that. So now we're going back to our loop. So first of all, okay, so first of all, we're going to, yeah, well, let's, just to keep track of it a bit nicer, while sum pointer equals next pointer, then we're going to get the next item. So next is equal to template dot get at pointer dot yeah, sorry, just pointer. Oh, sorry, it's not next, that is, so that's P1 next. This is a bit convoluted. P1 next and P1 is equal to that. And also if P2 next and P2 is equal to template dot get P1 next, then we can see if there's an addition. And that this unlike the rest is the same, so it's P1 P2. Okay, then we're going to add an insertion. So that's going to be okay, it's going to be at pointer, and the value is going to be the addition. So it's saying after pointer insert this. Okay, we can do that. Then at this point we can say that the next pointer is equal to P2 next. Otherwise, the next pointer is equal to none. This is the same as breaking, I guess. But there we go. And we now also need to change our logic for insertions. I don't think we need to reverse now, but we can keep that. So instead now we want to get that pointer. Equals, let's see, template dot get mute. Okay, so P1 next is now going to equal sum insert, let's see, new entry. And new entry is going to be something that we're adding into our template. So new entry is equal to max pointer plus 1, new entry, oh, and then we need to remember to increment max pointer by 1 as well. Okay, and then we can insert that into our template. So template.insert, that's going to be the new entry, and this is going to be sum. It's going to be orig p1 next. And then it's going to be the character, which is just the and then we can actually get rid of this sum because that's actually an option. It's always going to be sum, but that's aside the point. Okay, so we changed the one before what we're inserting to point to that, and then the thing that we're inserting points to the next one. The next one does not need to be changed. It looks like that should be good. So this actually is not too different. We now just need to say we want to iterate over the values. We don't care about the next, and we still do care about the character. So in principle, this all works. I'm sure I made a few mistakes here. Okay. Oh, actually what we can do here. Oh, no, because this isn't, yeah, what we can do here is just that. And same for this. Oh, actually, no. We want, okay, P1 needs to have a next one, but P2 does not. And now we are in reference hell, it looks like. And is that all of the stars we need? Okay, a possibly uninitialized. Yeah, we can say hashmap.new there. I guess this is fine without being mutable. Okay, so it looks like even the first ones aren't finishing. That's not because of performance, it's definitely because I've made a mistake somewhere, which isn't too shocking. This is some pretty ugly code. So I think one function that would be useful here is just a way of like printing the strings. Or I think it's important for us to be able to print the strings because the first two it looks like we're getting okay. So that's going to look like this. Okay, and hopefully that works, and hopefully we can see what that looks like, or see how that compares to our example. Okay, so it looks like it's even wrong after the first step. Okay, so it should be NC, NB, CHB, but instead it's NB, C, NB, CHCB. So first I want to see if the insertions are right. So I'm just going to debug those. I think that's how you give it a slightly nicer format. Oh, the next pointer here is just wrong. We just don't care about P2 next at all. And this is the same as breaking. Yeah, that's fine. Okay, so the example here now passes, so I'm just going to see if this finishes quickly enough to get an answer for part B. Or I guess for example 2 first. And we'll need to move these back. So this is still going, like, it seems really slow. And our example is even longer, so that's probably a bit more. Example 1 and part A do fine. So this is quite a bit faster than our vector. But it might not be enough faster to actually get an answer. Like, it's just pretty slow at this point. So another thing which is possible is just that so we need to know, we need to know the difference between the most common and least common. So there might be some kind of pattern here. All right, it's 60 seconds and we're only at 24 to 40. What do you get if you take the quantity of the most common element and subtract the quantity of the least common element? Wow, this does grow just very quickly. So I'm just trying to think. So one thing that might be promising. No, I was gonna say it'd be nice if, okay, so can we divide, the question is, can we divide this into subproblems? So if we have NN, we can see what that goes down to. Yeah, no, that's probably better. I think that the solution I have right now is just like not going to work, and then I have to start from scratch. So what we can do is we can see what the characters from NN are, I think. Need to think this carefully, and then what the characters for NC are, and then what the characters for CB are, because whatever the reactions are, they're not going to change. They're not going to change the first and last one. And then when we add them together, we need to remember to move that duplicate. Okay, so this basically is just, here I did not do some back of the envelope calculations, the ones that I should have, to realize that this is just totally impractical, even with like a linked list. But I think this approach will work fine. So lines is equal to that. We're going to go back to what we did before, I think. So template is just equal to a vec of, yeah, nope, first line is good. I'm just going to call that template now. We're going to remove this. We're going to still have our reactions, and then this is going to change. Okay. So we have here is a map from this from like first and last to a hash map of characters to counts. And here I'm going to make a function called count, which takes a first character, a second character, the reactions, which is from char to char, and then also, like it's still going, by the way. Just amazing how slow this is. Like, this is totally infeasible. Okay, and that's going to return a hash map from char to usize. Okay. So if let sum C equals reactions dot get P1, P2, then that's great. Then we can, then we're going to continue going down. But otherwise, it's pretty simple. We're just returning dot insert. Yeah, we're just returning the trivial thing, which is that there is one P2, and they could actually be the same here. So we're going to do counts.entry P1 for default plus equals 1, and same for B2. And then we're going to return counts. We still need to figure this one out. But we can also say, we also need our memo. So that's going to be that lovely type we have down there of from char to that hash map. What did I get wrong there? It's char to hash map. Great, okay, so if let's result equals memo dot get p1, p2, then we'll return a clone of the result. Okay, so now we have the tricky part. Okay, so first of all, we're going to do the first character to the middle character, so that is count P1, and then C, and then reactions, which is actually just going to be reference, and then our memo. And then we're going to say counts entry C plus equals 1. So this includes the first one and the middle one. And then we're going to do the same for C to the second one. And this includes the middle one and the last one. And now we just need to remove the middle one since that's counted in both of them. And we need to add this to the memo. So memo dot insert, this is P1, P2 leads to counts dot clone, something like that. And we need to return the counts. Okay, so what is this complaining about? Oh, I made the same mistake there. Okay, so for each of these, okay, so let's fix these errors first. So that one's easy. This needs to be that. Just adding 3 stars. And over in here, then we have, oh, there's more errors. Nope, that was fine the first time. Oh. Okay, no, that's right. And we're shadowing C here, which is kind of confusing. I need to remember that I'm doing that and probably clean this up later. All right, so now we have our counts variable. And we're just going to iterate over every pair. So we have for I in 1, 2, template.len. We're going to say for C count in count C, or count from, let's see, so P1 is equal to template at I minus 1, P2 is equal to template at I, And count is going to be, let's say P1, P2, reactions, and memo. So for all of those, we just do the same as before. Okay, now, in the first iteration, we are including both the starting character and the ending character. In the second iteration, we're including the starting character again. So, if this is not the very first one, so if I is not equal to 1, then we need to remove remove one instance of the first character. And this should still apply. Character size. Okay, max, okay, so we're doing counts, which is a hash map. I'm just going to say values, and then we can say max dot unwrap and min dot unwrap. And we don't know. It seems to infer it, at least in my editor, but just in case we'll do this. Okay, part A has overflowed its stack. I'm going to go back to just doing the first example, just to make the output more palatable. Okay, example 1 also overflowed its stack. Oh, right, we're not, let's see. This is just me, this is just a matter of me just not thinking super clearly. So this also needs, we also need the number of, we also need the number of iterations. That's going to be usize, and if there's no more iterations left, then that's going to be just an empty hash map. There's no, oh no, it's not going to be an empty one. It's going to be the same as this. Okay, and then we need to, when we're calling down, we need to include iterations here, and iterations also needs to go into the memo. Oops, this one. Something like that. And then instead of this, we do this. and right, our memo is now also incorrect. We need to add that. And this warning is helpful. It's saying that we're not actually including the counts, which is correct. And then it's saying it's overflowed its stack again. Iterations -1, thank you very much. And there appears to be one more issue with this. Oops. Now, unlike the previous one, this one is pretty difficult to debug, which is why I'm very happy that this first example passed. Let's see if part A in example 2 worked. They did, look at that, super fast. Okay, and so now we're going to do part B and see what that looks like. Okay, we have just a massive answer. And we got it right. All right, that was kind of an adventure. Thanks for watching.